Today, we're diving into the fascinating world of computer networks, specifically focusing on a protocol called UDP, or User Datagram Protocol. Imagine the internet as a massive highway system, bustling with activity and data flowing in every direction. Data travels these highways in packages called packets, which are essentially small units of data. Think of them as little digital envelopes, each carrying a piece of information to its destination. Now, these packets need directions to reach their destination, right? Just like how you need a map or GPS to navigate a city. That's where protocols come in. They act as the rules and guidelines for how data should be transmitted over the network. They're like the GPS of the internet, making sure your data gets where it needs to go efficiently and accurately. One of these protocols is UDP, and it's known for its speed. It's designed to be fast and efficient, perfect for real-time applications. Why? Because it's like sending a postcard. You just write the address and send it off without worrying about delivery confirmation. You just slap an address on there and chuck it in the mailbox, hoping it reaches its destination. No need to wait for confirmation or anything. This makes UDP incredibly fast, but it also means there's no guarantee the data will arrive intact. UDP stands for User Datagram Protocol. It's a connectionless protocol, meaning it doesn't waste time establishing a connection before sending data. Unlike TCP, which requires a handshake to establish a connection, UDP just sends the data without any formalities. Imagine trying to stream a live video while waiting for a handshake every few seconds. Frustrating, right? With UDP, you can avoid these delays, making it ideal for real-time applications like live broadcasts and online gaming. UDP is all about efficiency. It prioritizes speed over reliability, ensuring that data is transmitted as quickly as possible. It says, here's the data, take it or leave it. This approach minimizes latency, which is crucial for applications where timing is everything. No time for error checking or resending lost packets. This means that while some data might get lost along the way, the overall speed and performance are significantly enhanced. This makes it super fast, but also a bit unreliable. However, for many applications, this trade-off is worth it. Think of it like sending a message in a bottle. You send it off quickly without any guarantees. You toss it in the ocean and hope for the best, but there's no guarantee it'll ever reach its destination. Despite this, UDP remains a cornerstone of modern networking, powering countless applications that demand speed and efficiency. So when is UDP the better choice? Whenever speed is more important than absolute accuracy. Live streaming is a perfect example. You want that video smooth even if a few pixels go missing, right? Online gaming is another great use case. Imagine lag in a firefight, unacceptable. UDP keeps things snappy even if a few commands get lost in the chaos. VoIP calls also rely on UDP. Sure, a little crackling is annoying, but it's better than robotic voices and delays. Section 4. UDP in action, from streams to games. Let's get a bit more technical, just a bit. Imagine you're streaming a movie. Your computer sends out a constant stream of UDP packets. Some might get lost, but that's okay. The video player can usually fill in the gaps without you even noticing. In online games, UDP lets your computer send rapid-fire updates about your character's position, shots fired, and all that good stuff. Even if a few updates get dropped, the game can usually compensate, keeping the action smooth and responsive. Section 5. UDP versus TCP, a head-to-head matchup. In this section, we will dive deep into the differences and similarities between these two fundamental protocols that power the internet. Now let's compare UDP to its more cautious cousin TCP, or Transmission Control Protocol. While both are essential for different types of data transmission, they operate in distinct ways. TCP is like a registered letter. Just as a registered letter requires a signature upon delivery, TCP ensures that every packet of data is acknowledged and received correctly. It needs a signature on delivery, ensuring every bit of data arrives safely. This meticulous process guarantees that no data is lost or corrupted during transmission. This makes it perfect for downloading files, browsing the web, and other tasks where accuracy is paramount. Whenever you need to ensure that the data you receive is exactly what was sent, TCP is the protocol of choice. But all that checking and resending takes time, which is why TCP is slower than UDP. The constant verification process can introduce delays, making it less suitable for real-time applications. So, there you have it. TCP is reliable but can be slow due to its thoroughness. UDP is the speed demon of the internet, sacrificing a bit of reliability for blistering performance. It sends data without waiting for acknowledgements, making it much faster. It's the go-to choice for applications where speed reigns supreme, keeping your streams smooth, your games lag-free, and your calls connected. Whether you're gaming, streaming, or on a VoIP call, UDP ensures minimal delay and maximum performance.